Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for over a decade, and I've achieved a 99th percentile GMAT score and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS believe that our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Real GMAT Problems, episode 44. Doing real GMAT problems is one of the most proven ways to make test day go well. So let's talk through a few examples. The problems we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions that we're going to work through here. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be really, really similar to what you're going to see on your official GMAT. Standardized tests are designed to change very slowly over the decades, and the GMAT is no exception. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what to take away from each question. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. You may not be able to get through all the steps in your head like you would if you could on test day, but just do your best. If you are in a situation where you can physically write down what you would if you were actually in the test center, then that's definitely ideal. We're going to start with a lower difficulty level warm-up problem, and then we're going to bump up the difficulty level from there. In fact, we're going to start stretching the difficulty level a bit higher today than we have in the past, quite a bit higher. So don't worry if these questions are a little too difficult for you right now. Feel free to go back into a lower numbered episode of the series. We're on 44 now, so there's 43 other episodes you can do with questions that are steadily increasing in difficulty over time, and work your way back up to where you can feel confident on these. Today, we're going to be talking about work questions, rate and work questions. Here's our first problem. The problem says it would take one machine 4 hours to complete a large production order and another machine 3 hours to complete the same order. How many hours would it take both machines working simultaneously at their respective constant rates to complete the order? I'll read that again. It would take one machine 4 hours to complete a large production order and another machine 3 hours to complete the same order. How many hours would it take both machines working simultaneously at their respective constant rates to complete the order? Option A is 7 divided by 12. Option B is 1 1/2. Option C is 1 5/7. Option D is 3 1/2. And option E is 7. Again, recommend pausing, getting as far as you can. I'm just going to jump into my commentary here so we don't have a bunch of dead air for you. So really good warm-up problem for work questions, and it's a good way to revise a concept that we've spoken about actually quite a bit in the past for rates questions, which is the rate chart. Rate charts can work really well because they're basically a specific way of using rows and columns, which we've talked about a lot in relation to word problems, in relation to visual organization, and in relation to helping you make hard problems easier. What I think we're going to see as we go through this question is that it's more of an organizational challenge than a mathematical challenge. And that's not true of every work question, but it's true of a good number of them. So I'll do my best to emphasize the good habits that I think are going to help you the most as you move forward with these. The first good habit is to become consistent with making the rate chart each time you see a rate question. And a good signal you're looking at a rates question is when you literally see the word rate or rates like we see here. So again, just going back to the problem, blah, 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 working simultaneously at their respective constant rates. As soon as you see that word rates, you think, okay, I could probably use a rate chart here. Again, the rate chart is just a specific instance of simple rows and columns. We've talked about rows and columns a ton on the pod, so we've done our best to make all these episodes searchable. So if you search word problems or you search rates, you should find some good lower difficulty level questions that deal with the rows and columns approach. For now, I'm not going to cover that again. I'm just going to go straight into the rate chart, and I think you'll see how it is just a specific instance of rows and columns. But again, if you want a little bit more instruction on the basics, then feel free to go back in the feed to an earlier episode. So your columns will always be the same in rates questions. The first row is rate. The first column is rate. The second column is time. And the third column is work or distance, if it's a distance problem. We're going to focus on work today, but there's a lot of commonalities between work and distance questions. And one thing they have in common is how useful the chart is. So that's going to be the very first thing that I would write here. I would write rate times time equals work, and those will function as my 3 column labels. Then each row label will be whatever thing is working in the problem, whatever they're telling me is doing work. Usually each thing that's working gets its own row. For example, we're told it would take one machine 4 hours to complete a large production order. So my first row label would just say machine 1. So across the top of the chart, I've got rate times time equals work. To the left of the chart, where the first row would be, if you visualize like a spreadsheet. You can also see this on YouTube if you want to see how I would draw this out. But if you're on the pure audio feed, I'll just describe it for you. So my first row label would be machine 1. We're also told another machine 3 hours to complete the same order. So my second row would be machine 2. So I've got 2 rows right now, machine 1 and machine 2. From there, I could start to fill in the information that they give me about rate, time, and work. In this case, we're given information about each machine's time and each machine's work. For machine 1, we're told that it can complete 1 order. So I would just write 1 order under the work column to the right of machine 1. We're told it can complete that order in 4 hours. So let's write 4 hours under the time column, also to the right of machine 1. So I'm just filling in machine 1's row of rate times time equals work. We're also given information about machine 2. It can complete the same order as what they tell us. So again, I'd write 1 order under the work column to the right of machine 2. Machine 2 completes that order in 3 hours. So I would write 3 hours under the time column to the right of machine 2. So there's a lot to like about the rates chart. I'll talk a lot more about the virtues of it, but one of the main things that I really like about it that I think a lot of people underestimate is how simple it is to set up. And what I like about that is it can get you a lot of momentum in these questions, where I found a lot of people kind of freeze on these word problems, especially rate problems. I think sometimes the mind can get going and it can start to work against us a little bit, where it's telling us things like, hey, you should know how to do this. This isn't that hard. Why are you struggling? And like, perhaps obviously none of that affects your performance positively on the question. So it's nice to be able to just default to a set of actions that you know is productive and also doesn't take like too much brain power. I mean, if you think about it here, it probably didn't take me a ton of effort to be like, oh, it says the word rates. I'll make a chart. My chart is rate times time equals work across the top, 2 machines. Those are my rows. They tell me the work. They tell me the time. Like, it's quite thoughtless. And I like that at the beginning of what could potentially be an intimidating problem. And I hope you like it too. And I found it kind of just calms the mind, gives me something to focus on, gets me out of my head. And it automatically helps me start to strategize around how I might approach the rest of the question. So maybe you're way more talented at rates questions than I ever was and still am. And if you already have an approach that's quite different from this, that's getting you amazing results, that's awesome. Keep doing what you're doing. I'm here to help you get results. If you're already getting results, don't stop what you're doing. If it's not broken, don't fix it. But if you're struggling to get results on rates questions, or you identified with that, like, I'm freezing up on these questions mentality, hopefully the rate chart's going to help a lot. So once you've got all that filled in, you'll often be able to solve for other elements of the chart. And when you can, it's usually almost always a good idea to do that. So that's going to be my next step. And I'll show you a few more examples of this as we go through the lesson. So if this goes by a little quick, don't worry, we're going to do quite similar stuff on the next couple problems. So in this question, you may notice that each of our rows can be written as an instance of the rate times time equals work equation. And that's part of the virtue of the chart. It's just a bunch of rows that are rate times time equals work over and over again. So a good way to visualize that is just put an equals sign between the time and the work columns in each row. I'll usually write an equal sign in each row that I'm working with. And I like to write a multiplication sign in each row between the rate and the time columns. So I have rate times time equals work across the top. Then if I had machine 1, I would have a blank under the rate because I haven't been told anything about that. And then I would have a multiplication sign there. And then I would have the time, and then I'd have an equal sign, and then I would have the work to the right of that. And I would do that in machine 2's row as well. It just helps remind me what the data in the table represents. If that makes sense. And this might seem small, it might seem overly detailed, but when you get to hard rates questions, usually it helps. Usually it helps, as weird as that might sound. So one of the ways that can help is it can help you see that you need to multiply the rate times the time to produce the work. Again, that might just sound comically obvious right now, but like under pressure, even the most obvious thing can become difficult. So in this particular case, for machine 1, we can find a rate that multiplies by 4 hours to produce 1 order. So you just ask yourself, what number can I multiply by 4 to produce 1? So I'm looking at that first row of the chart. I've got a blank in the rate. I've got 4 hours for the time. I've got 1 order for the work. I think, okay, what's the rate that I could multiply by 4 to get 1? And hopefully you're thinking 1/4. If I multiply 4 by 1/4, I'll get 1. So I would take the time to write out 1/4 orders per hour in machine 1's rate column. And you'll notice I'm being very heavy-handed with my recommendation of writing the actual units into the table. Might seem like a waste of time, might feel like you don't have time to do it. I would say in 99% of cases that I've ever seen, which is a heck of a lot of cases at this point, that helps people a ton. It helps people connect the dots between the pieces of information. It helps avoid missing questions you know how to do. And if you've been studying for a while, you probably know that both of those things can be significant challenges in the quant section. Missing questions you know how to do is usually a big challenge. Freezing up is usually a big challenge. We talked about that already. And then just figuring out what is the next step and how do all these pieces of information connect in this word problem, that can also be a big challenge. So hopefully we're starting to solve that with some simple but really powerful suggestions here. You probably will notice we can perform the same thing for machine 2. What's something we can multiply by 3 hours to produce 1 order? Hopefully you're thinking 1/3. So I would also write 1/3 orders per hour, or 1/3 orders over hours in machine 2's rate column. Again, if you're getting 100% of these rates questions right without this level of organizational discipline, then keep doing what you're doing. But if you're struggling with rates questions, I think you're going to find that this chart really helps in a few different ways. Like I said, helps avoid mistakes. When you're writing things out this clearly, you should be able to catch a lot more problems before they happen. A lot of people simply write something down improperly in questions like this, and that leads to a significant number of mistakes. I'll show you in a bit how that plays out on this question. In fact, by the numbers, there's one answer that overwhelmingly people pick that's wrong, and I think you'll probably come to the same realization I did when we talk about that, which is it's an organizational problem. The people actually knew how to do the math in the problem, but they just got disorganized, and so they picked the wrong number in the wrong place. Happens all the time, and it's super painful. Perhaps obviously, it's really, really painful reason to miss a question. So that's the first advantage of the rate chart, helps you avoid mistakes. Second advantage, it helps you see the connections between pieces of information that might not be obviously related. I was just talking about this as well. Usually a big challenge in work questions. In this particular case, it can help you see that the key next step of the problem is that you want to add the 2 individual rates in order to get the combined rate. So let's dig into that a little bit. This is a really common move when people, machines, robots, that kind of thing are working together. If we work together, usually the work gets done faster. What can be less intuitive, though, is that you simply add the individual rates to get the combined rate. So how does that work? A more intuitive way to think about that, if it's helpful, is imagine one robot can build 4 cars in an hour, and another robot can build 7 cars in an hour. If they work simultaneously, how many cars can they produce together in 1 hour? Hopefully you're thinking 11. First robot makes 4, second robot makes 7. At the end of that hour, 11 total cars have been made. And I think those kinds of examples are a little bit more intuitive because there's a whole number of things being made per hour, and that can make it a little bit easier to visualize. The only difference in this question is that we have fractional rates. So 1/3 of an order per hour for machine 1, 1/4 of an hour. Is that machine 1 or machine 2? Thank you. Yeah. So 1/3 of an order per hour for machine 2, 1/4 of an order per hour for machine 1. But it's the exact same concept. You add their individual rates to get the combined rate. It's usually just a little bit harder to visualize that because we're not used to thinking about a machine building 1/3 of something, unless you work in a factory with a lot of robots, in which case it's probably quite natural for you. So if you know that tactic and you organize everything well, you've got a very high likelihood of getting this question right. So what I recommend here is making a together row below the other two, or like M1 plus M2, whatever feels natural for you for that row label, and then write the sum of the individual rates into the rate column. So we'll do that math in a second. You'll also, on the far right of that final row at the bottom, want to write one order, because the question asks us, how many hours would it take both machines working simultaneously at their respective constant rates to complete the order? So the amount of work being done, even when they're working together, is still just one order. So I want to depict that in my chart. Otherwise, it's going to make it kind of hard to finish the problem out. So let's go ahead and add the individual rates. 1/3 plus 1/4. You find a common denominator. 4/12 plus 3/12 would be a common way to do that. That gets you 7/12. And if it's been a while since you've done some fraction math, if you're just starting out on your GMAT journey and this is one of the first touch points you've had with the exam, then please check out our math basics episode on fractions linked below if you want a little bit of reskilling with fractions. Might have been a while since you've done fraction math by hand if you're like most adults starting to study for this process. So we'll write 7/12 in the rates column next to the M1 plus M2 row, or together row, or sum row, however you want to label that. I'll call it M1 plus M2 for now. So I would write 7/12 orders per hour. Okay, so we've got 7/12 orders per hour. Then we've got the time column blank for that last row. And then we've got one order in the work. So what amount of time would I need to multiply 7/12 by to get 1? So 7/12 orders per hour times how many hours equals 1. Hopefully you're thinking 12/7. If we convert 12/7 to a mixed number, and feel free to check out our math basics episode on remainders for help with mixed numbers if you want. If it's been a while since you've thought about what a mixed number is, that's fair. That would get us 1 5/7. And that gets us to our correct answer of option C, as in Charlie. So that's a quick rundown of how you can create an organized approach to work questions. Let's circle back to why that can be so valuable. The most common incorrect answer here is option A. And you might recall that that's 7/12. Why might so many of us go for 7/12 instead of 12/7? Well, it's really easy to mix up rate and time. Super, super easy, especially if you're taking an algebraic approach to the question, which is possible here. You're using variables, setting up equations, solving with algebra. You get to the end and you say, oh, cool, equals 7/12. Very, very tempting to pick A at that moment. So that's where the chart can come in really, really, really handy. Makes it easier to see connections, like adding the rates. We were just talking about that, but it also makes it less likely that you're going to pick a correct number from the answer options that represents the wrong thing. Much less likely to get mixed up if you have everything super clearly labeled. And apparently, that alone can increase your odds of success on this problem by about 12%. About 12% of us end up going for A. So think about how heart-wrenching that is. If you got 7 over 12, you probably knew exactly how to do the problem strategically and mathematically. And yet, on a multiple choice test, if I don't pick the exact right answer, it doesn't matter if I did 99% of everything else right, it's still a 0. So the bar is pretty high. The bar is pretty high, and that's part of the reason I'm recommending setting the bar high for your process. Just to tie this off, if there's one skill that I've found that is the most foundational for getting work questions and really all word problems right, it's good organization habits. Just gave you my preferred way of organizing these, but as long as you have something consistent that works for you, you should see the success you want to see on these. If you struggle with your method, though, you can always come back to this one, and I think you'll find it quite helpful, meaning you can always return to the rate chart if the way that you are currently doing it or the way that you eventually do it ends up not yielding the results you want. For now, if there's anything beyond the rate chart itself that you'd like to recall from that discussion, then I'd recommend you pause here and just make a quick note to self. If you're on the go, just text or email yourself. And if you're at the desk, maybe make a flashcard or add to your takeaway list or notes list, whatever you're using to track away what you learned, to track what you learned from each problem. Then I'd recommend adding to that. And if you're making the note to self while you're on the go, I'd recommend adding it to some type of list like that when you're back at the desk. It's really easy to think that just completing problems moves the score. But I think if you step back and think about it, you'll realize an important truth, which is like completing problems does not necessarily move my score. It's learning from problems that moves my score. And it's very tempting to think that those are the same two things. So if you're not tracking your takeaways on a problem by problem basis, like, okay, what did I learn from this one? What did I learn from this one? What did I learn from this one? How do I remember that? How do I remember that? How do I remember that? If you don't have a good system for that, simple paper and pencil or simple spreadsheet with the learning from each time you do learn something. If you get 10 problems in a row right, there might not be a lot of additional learnings there. That's okay. But eventually you'll challenge yourself, you'll miss some questions, and you'll learn from those. Flashcards are a really, really good, simple way to make those learnings automatic over time. And as I've recommended in a lot of our how to study content, which there's plenty of in the feed, it's also a great idea to keep a list of actual problems that you found hard the first time you saw them, and it's a great idea to resolve some of those every time you start your study session. It's a great little warm-up, and it'll really help you retain the information that you're learning and build knowledge rather than just exposing yourself to a lot of stuff. It's a big, big problem with this exam. A lot of us haven't studied for exams where you have to study for like months and months and months and still retain what we were studying 6 months ago or 3 months ago. So that'll help. That'll give you a really, really, really big advantage. Okay, that's more than enough on our warm-up problem. Let's bump the difficulty level up just a little bit here. Our second problem says, two machines, Y and Z, work at constant rates, producing identical items. Machine Y produces 3 items. In the same time, machine Z produces 2 items. If machine Y takes 9 minutes to produce a batch of items, how many minutes does it take for machine Z to produce the same number of items? I'll read that again. Two machines, Y and Z, work at constant rates, producing identical items. Machine Y produces 3 items. In the same time, machine Z produces 2 items. If machine Y takes 9 minutes to produce a batch of items, how many minutes does it take for machine Z to produce the same number of items? Option A is 6. Option B is 9. Option C is 9 1/2. Option D is 12. And option E is 13 1/2. And again, we've got the actual problem on the screen on YouTube, but if you're on the pure audio feed, hopefully I've repeated that enough. You can always give us feedback at any time. We've got a feedback link in the description of every episode, everybody. Okay, get as far as you can there. And I recommend pausing to do so. And I'm just going to jump into my commentary here. So, great follow-up question. It's not too much harder than the previous one, but it's definitely a bit more challenging. I think it's a little bit more complicated to decipher, and by the numbers, it definitely more of us missed this one. About 50% more of us missed this one than the previous one. So that's definitely quite a bit more difficult. Takes a lot of the same concepts though, and it just adds a little bit more complexity. So it's a good way to test and build your understanding of what we were talking about in the first problem. So once again, note that the word rates appears. So it says two machines Y and Z work at constant rates. And that's a good signal that you'll want to make a rate chart. So let's build one. Once again, I'm just going to put rate times time equals work across the top as the 3 column headers. And then let's make a row for machine Y. And we're told that Y produces 3 items in the same time that it takes Z to produce 2 items. That's a little bit less straightforward than our previous question, but we can at least write in the amount of work that each one does. So let's do that. So to the right of Y, I'm going to write 3 items under the work column, and then I'm going to make a row for Z, and I'm going to write 2 items to the right of machine Z under the work header. Like I said, this is one moment where this question's a little bit tougher than the previous one, because instead of just giving us a number for the time that each one takes, like the previous problem did, it just says in the same time. And when you see things like that, you'll usually want to make a variable. That's because we're not given a specific value for that time. It's an unknown. But we do know that is the same time for both machines. And for some of these more challenging questions, like you probably won't have that insight the first time you see the question, but that's okay. That's why you're practicing. The 3rd, 4th, 5th, 6th time you see a question like this, and it comes up plenty, it'll be a lot more intuitive for you. So you just got to start somewhere, kind of make the mistake. Like I said, flashcards, having that list of questions to redo on a regular basis, super powerful for helping you speed up your pattern recognition here. So I'm just going to choose the variable t to represent time, and I'll write that for the time in each row, because once again, we don't know the time, but it says it's the same time. So whatever t represents, it's going to be the same value in both cases. So the machine Y row is blank under rate, and then t under time, and then 3 items under work. The machine Z row is blank under rate, then t under time, and then 2 times under work. And if you're on YouTube watching, I'm spelling all this out for the people who are on the pure audio feed here, because they can't see what I'm writing. So hopefully that helps you see that now we can solve for each machine's rate. So let's do that. What would I need to multiply t by in order to produce 3 items? Think about that for a second. It's actually the same question I was asking you before. What rate would I multiply the time by to produce the work? So what would I need to multiply t by in order to produce 3 items? If you think about it, it might be a little bit less intuitive than the previous question, but if you multiplied by 3 divided by t, then the t would cancel out of that fraction and you would just get 3. So 3 over t times t equals 3. So I would write 3 over t items per minute. And just circling back on that, we're told in the original question that the unit we want to solve in is minutes. We're asked how many minutes. So that's how I knew to use that as the time. So if I multiply 3 over t items per minute times t minutes, I'll get 3 items. So there I've got my rate for the first machine. Let's do the same thing for machine Z. What would I need to multiply t by in order to produce 2 items? Hopefully you're thinking 2 over t items per minute. So if I multiply 2 over t items per minute times t minutes, that'll yield 2 items. Okay, so now we've got our chart filled out. What do we do next? This one's a little bit different. Instead of working together, we're told that Y produces a certain number of items in 9 minutes. that's going to conflict with our original row for machine Y. And that can happen sometimes in work questions. And the way around that is just make an additional row for machine Y below your existing rows. I'll do that right now. I'll just write machine Y again under the machine Y and machine Z rows that I already have. And I'll write 9 minutes in for the time there. And the whole purpose of the rate times time equals work chart is to organize multiple instances of the rate times time equals work equation. So it's okay if you have multiple equations, even for the same machine. So again, the first time you see that might be a little bit weird, but that's okay. The whole point of seeing it the first time is it'll be easier to see the third time and easier to see the sixth time. And by test day, hopefully like, oh, it's another one of these. And that's what we're trying to do. Having said that, this is another moment where this question can feel a little bit harder than the previous one, maybe a lot harder. That's okay. If you are finding this one hard, you're here to learn. Growth happens at the edge of the comfort zone. So in a way, if you're a little uncomfortable, that could be a positive. That could be a sign you're confronting your prep the right way. And it's okay if you're not comfortable with it yet. You'll adapt. So we're told that Y takes 9 minutes to produce a certain batch of items. And then we're asked how long Z would take to produce the same number of items. But what's annoying about that is we don't know how many items that is. And in those cases, you just want to figure out a way you can solve for that number of items. So let's see if we can solve for it. If you recall, we already know that machine Y produces items at a rate of 3/t items per minute. And because we made a new row for the same machine, we can just bring that rate down to our new row for Y. Remember, the problem says they work at constant rates. So once we solve for machine Y's rate as 3/t items per minute, we can use that in any new instance of a row for machine Y. So that's what I'm doing there. I'm just taking 3/t that we calculated in the first row, moving it down into the third row. So I've got 3/t items per minute, and I know that it's working for 9 minutes, and that will let me solve for how many items it can produce in that time. So I've got 3/t items per minute times 9 minutes. That gets me 27/t items. Again, if you're a little fuzzy on that fraction math, just check out the Math Basics episode we've got for you on fractions, and that'll start to make a whole lot of sense. So the question's asking us how long it's going to take machine Z to produce that number of items. But if I want to put that into the chart, that's going to conflict with my original row for machine Z. That's okay, though. I'll just make a new row for machine Z at the bottom of the chart, and then I'm going to write 27/t items under the work column. Now, the question's asking me to solve for Z's time to create those items. But in order to do that, I would need to know machine Z's rate. The good news there is we already solved for machine Z's rate earlier in the question. We know machine Z creates items at a rate of 2/t items per minute. So let's write that in our new row. So in the new row at the bottom of the chart for machine Z, we would now have 2/t items per minute written into the rates column, nothing in the time column because that's what we're trying to solve for. And then we would have 27/t written in the work column. I want to multiply 2/t items per minute times something in order to create 27/t items. What would I need to multiply by? That might be a little tough to do in your head. So if you want, you can always make an equation outside of the chart if you want. So each row in the chart, remember, is just an instance of rate times time equals work. So I could just pop that out of the chart, or I could even do it in the charts. This is the bottom row. I'd have 2/t items per minute times p minutes. I'm just choosing p as in purple as a variable, but it could be any variable there, equals 2/t items. And then I can just solve for p. Check out our Math Basics series on algebra if you find you're a little rusty there. So I'm just going to divide both sides by 2/t in order to isolate p. That's the same as multiplying by t/2. And that's going to get me p equals 27/t times t/2. Note that the t's are going to cancel there. And that's going to get us p equals 27/2. And if you convert that into a mixed number, that will get you 13 1/2, which gets us to our correct answer, which is option E, as in echo. Okay, so what can we learn from that? My guess is that there are a few places where people are struggling on this one. Number one, they may not have a system for organizing the original data at all. So hopefully I've done a decent job explaining the rate chart, or maybe even better than decent, hopefully, fingers crossed. And hopefully that can help you. Second place people are probably getting bottlenecked here is they may not have been able to figure out how to manage the variable for t. Hopefully I gave you a good trigger for when to make those variables and how to use it in the chart. If you don't remember that, the great thing about this content is you can rewind it. So if you go back a few minutes, I'll talk through that for you again. And the third place I think that people are probably getting stuck here is they're unsure how to manage the new information about the 9 minutes piece and figure out the new number of items being produced. Hopefully, just adding some rows to the chart can help you out. If you got stuck there, you don't already have a system for handling that kind of duplicate information. Quick note, rates and work questions generally require more practice to get really comfortable with than other problem types. I don't know exactly why that is, but I think there's this additional level of complexity and maybe just counterintuition involved in these. And it's not always the case, but it's super common. It was definitely true for me back in the day. It took me a lot longer to get comfortable with rates than I wanted it to. So please don't stress if it's not coming naturally or it's not coming quickly. Just come back to this episode a few times in the coming days. Like we were talking about, resolving problems you've already seen can be surprisingly helpful. I think a lot of people don't think that that would be helpful on the surface. Just feels like new problem, new problem, new problem is what I need. But I think you'll find a lot of value even in just resolving a small handful of questions, and repeating this pod could be a great way to do that after a couple days to see if you can remember some of the techniques and perform a little bit better the second time around. Again, recommend pausing here. If there's any notes to self to make about what you'd like to recall for questions like this in the future, I'd recommend making those now. And we'll bump up the difficulty level quite a bit here when you come back. Third problem here. Problem says pumps A, B, and C operate at their respective constant rates. Pumps A and B, operating simultaneously, can fill a certain tank in 6/5 hours. Pumps A and C, operating simultaneously, can fill the tank in 3/2 hours. And pumps B and C, operating simultaneously, can fill the tank in 2 hours. How many hours does it take pumps A, B, and C operating simultaneously to fill the tank? Let me read that again. Pumps A, B, and C operate at their respective constant rates. Pumps A and B, operating simultaneously, can fill a certain tank in 6/5 hours. Pumps A and C, operating simultaneously, can fill the tank in 3/2 hours. And pumps B and C, operating simultaneously, can fill the tank in 2 hours. How many hours does it take pumps A, B, and C, operating simultaneously, to fill the tank? Option A is 1/3. Option B is 1/2. Option C is 2/3. Option D is 5/6. And option E is 1. Again, recommend pausing and getting as far as you can. It's a great one to round out the discussion for the day. By the numbers, this one seems quite a bit harder for folks than the previous two, and definitely a really high difficulty level overall, with only 30% of us getting this right. So about 70% of us get the first one right. About 70% of us get this one wrong. I double checked the data. I'm a little skeptical of that, but so far it's checking out. So I was a little surprised by how often we tend to miss this kind of thing as a group. But having done this for a really, really long time with a ton of folks, It does make sense. Let's talk about all the potential pitfalls here. Once again, you're going to notice the word rates in the question right off the bat. That's a good signal that the chart's going to be helpful. And so hopefully for all of you, having worked through those previous two questions with a lot of organizational discipline and care, hopefully this question got a lot easier. But we'll see. At least hopefully the first steps got easier. So I'm going to make the chart again. Rate times time equals work across the top. And then I'm going to get my first row labeled as A plus B. Under work, I'm going to write 1 tank. Under time, I'm going to write 6/5 hours. So again, just, I don't want to say mindlessly copying what the problem gives me, but like that's close. That's close to the mindset I'm in there. Just kind of like mirroring whatever's on the screen. I'll make another row for A plus C. Under work, I'll write 1 tank. And under time, I'll write 3/2 hours. I'll make a third row for B plus C. Under work, I'll write 1 tank. And under time, I'll write 2 hours. Then at the bottom, I'm going to write A plus B plus C. And under work, I'm going to write 1 tank. And then I'm going to write a question mark under the time column to remind me that that's what I'm looking for. I didn't introduce that specifically in the first two questions, but it would have worked great there as well. And so I do like to get ahead of that once I get a little bit more familiar with where these questions are going. And I think it's valuable to be able to see like, okay, here's what I have. Here's where I want to go. But if you find that distracting, don't worry about it. It's not essential, but I'd say most people find it helpful. Much like the previous two problems, we want to solve for the rate. So let's do that. For A plus B, what can we multiply 6/5 hours by to get 1? Hopefully you're thinking 5/6. So let's write 5/6 tanks per hour under the rate column for A plus B's row. Same thing for the next row. For A plus C, what can we multiply 3/2 hours by to get 1 tank? Hopefully you're thinking 2/3. So let's write 2/3 tanks per hour under the rate column to the right of A plus C. For B plus C, what can we multiply 2 by to get 1? Hopefully you're thinking 1/2. So again, we'll write 1/2 tanks per hour under the rate column to the right of B plus C. Interestingly, much like the first question, all three of them are working together in this case. So that should give you a strong suspicion that you're going to want to add up the rates. Now, where I think a lot of people probably go at this point is they'll make 3 equations. They'll do A plus B equals 5/6 for the A plus B rate. They'll make A plus C equals 2/3 for the A plus C rate, and they'll make B plus C equals 1/2. And they'll start using substitution, which is a common multiple equation solving tactic to solve for A, then solve for B, then solve for C. And the interesting thing about that is it would definitely work. That would definitely work as long as you don't make any math mistakes. But I'd like to introduce you to a really nice shortcut that leverages the chart a little bit more and will probably help you save a lot of time and a lot of steps. So if you've labeled all your rows carefully, you might notice that we can add A plus B, A plus C, and B plus C to get 2A plus 2B plus 2C. If you didn't notice that, no worries. It's a very like GMAT specific type thing to have you do. Not necessarily the type of thing you might have done in your grade school or high school or college math courses, but maybe. But it's something that the GMAT exam really likes. So if we add all those up and then we just divide by 2, that would get us directly to what we want, which is A plus C plus B together. And that would keep me from having to solve for A individually, solve for B individually, and solve for C individually. So it's a really nice little shortcut there. Let's go ahead and do that. So A plus B's rate is 5/6. A plus C's rate is 2/3. B plus C's rate is 1/2. So let's find a common denominator. I'd probably choose 6. So I would add 5/6 plus 4/6 plus 3/6. If you feel like I'm moving too fast, just go ahead back to that Math Basics episode and check out the episode on fractions. And that gets us to 12/6. And of course, that reduces to 2. So that would be 2 tanks per hour. So if I made that into an equation, if I had A plus B plus A plus C plus B plus C, if I like stacked that vertically, and then I put an equal sign, and on the right side stacked 5 over 6 plus 4 over 6 plus 3 over 6, I would wind up at the bottom with 2A plus 2B plus 2C equals 2 tanks per hour. I want to know what A plus B plus C is, though. So let's just divide both sides of that equation by 2. And that gets us A plus B plus C equals 1 tank per hour. Let's fill that into our row for A plus B plus C in the A plus B plus C row in the chart. 1 tank per hour times what number equals 1 tank? Hopefully you're thinking 1 hour. And that leads us to our correct answer of option E, as in echo. Okay, so again, I'm a little suspicious of the data there. Seems like 30% of us getting E right is much lower than what I would expect. But a lot of people go for D. A lot of people go for the other answers. So if you wound up going for those, that's okay. It's a good learning opportunity. Like nobody's going to know that you got that problem except you and me, and maybe some other people you're in the car with or something. But hopefully they're very, very understanding and supportive people. So... So who cares if you're getting these questions right now? All that matters is, are you going to get them right on test day? And if you're struggling with them now, you're definitely increasing your odds of getting them right on test day. So it's a positive struggle, a desirable difficulty. So that one might have felt natural, but if you're like most of us, it probably did not feel natural for you just yet, especially if you're early on in your studies. If you're a little bit more further along, then maybe that was no big deal, hopefully. Either way, hopefully we can agree that you're more likely to get the question right and get it right quickly if you have a strong system of visual organization. That's the main thing I want to emphasize for all of you today. If the rate chart is appealing to you, I highly recommend it. If you want to develop your own system, you're welcome to. If you're already getting amazing results with your current approach, no need to change. If you've struggled with work questions in the past, I'm really hopeful that our discussion today is going to make a big positive difference for you. If you have any questions about any of this material, you can always reach us at the GMAT strategy on current social channels, or you can email us at contact, CONTACT, at thegmatstrategy.com anytime. On that note, if you're struggling with your studies, or you're not happy with the results you're getting with your current provider, or you'd like to reach your goal faster, or you're dealing with score decreases, score plateaus, and you're unsure how to get around those, we do offer a free service on a limited basis where you can book a call with us. We'll take a look at your situation. We'll give you some advice about how to proceed more efficiently. There's no obligation for the call. We offer it in part because I struggled so much with this process, and there was really no help available to me back at that time. And I really, really, really needed that help. I almost gave up multiple times. Fortunately, I didn't. I'm glad I didn't. But yeah, basically I studied for like 6 months. My score went down from my first practice test. Studied for another 3 months. My score went down again. You can imagine how that felt. Wasn't feeling too confident in my ability to succeed in the process, okay? But the truth was, it wasn't that I didn't have the ability to succeed. I just lacked the proper framework. The GMAT is a very, very different test from other exams. It seems like a very similar test to other exams on the surface, but underneath that surface, it's quite different. And so we're trying to provide for you what I did not have back in the day. And as I say at the start of every single one of these episodes, your leadership matters, and we want to support you however we can. Again, no obligation or fee for the call. If you're interested in that, just head to thegmatstrategy.com, our website, which is linked in the description, and take a quick look at the free video on the landing page there on how you can reach your dream GMAT score faster. And if that resonates, you'll be able to share a little bit more about your situation and book a call from there. If you're interested in working with us directly long-term, we do offer paid support on a limited basis. Each program is customized for the individual. So if you're interested in learning more, just head to the site, check out the video, like I said, make sure our style seems like it could be a fit for you. And then you can book a call using the same link, and just let us know either in the form that you're going to fill out to tell us about your situation, or on the call directly that you're interested in exploring working together. Otherwise, we always default to just giving advice. And if you are interested in working together, we appreciate the trust on that. And we're happy to share if it seems like our programs would be a good fit for you or not. Even if we're not a good fit to work together on either side, we'll still set you up with some really powerful adjustments to your current approach and your current study plan, like we do with our free calls. If you're not interested in booking any calls, if you're already having the success you want to see, if your studies are progressing at exactly the pace you want them to, then by all means, please keep doing what you're doing. We'll be back soon to support your success for free right here. As always, my greatest hope is that this material is going to make your studies as easy and as painless as they can possibly be. Please stay positive and stay consistent with your prep, everybody. Talk to you all soon.